Hey everyone! Today we're diving deep into the very heart of how a Python program thinks. We're going to go from simple math all the way to complex decision making, and we'll pull back the curtain on the core building blocks that really bring code to life. So let's get right into it.
So let me ask you this. What's the real difference between a pocket calculator and a computer program? Well, it all comes down to one single crucial skill, the ability to make decisions. And that leap, that's exactly what we're about to explore.
First things first, we're going to start with something we can all wrap our heads around. Using Python as a super smart calculator. This is the foundation that everything else is built on. You know, at its most basic level, the Python interpreter is kind of like having a direct conversation. You type in a math problem, you hit enter, and bam, it spits the value right back at you. It's the simplest, most direct way to start playing with the language. For example, take this, 50 minus 5 times 6. Now, you might remember PEMDAS from school, right? Order of operations? Well, Python does too. It knows to do the multiplication first, then the subtraction, which correctly gives you 20. Pretty straightforward. So this table here, this is basically our entire math toolkit in Python. You've got your basics, of course, but then you've got these other really powerful tools, like integer division, that double slash, which just gives you the whole number, and the modulo operator, the percent sign. That one's cool. It only gives you the remainder. Trust me, these become incredibly useful down the line. And just like in algebra class, whenever you need to take control and change the order of things, you just use parentheses. See how this forces the subtraction to happen first? It completely changes the final answer. It's how you tell the computer, no, do this part first. You're in complete control. Okay, so doing math is cool and all, but let's move on. For a program to be truly smart, it has to be able to answer questions. Not super complex questions, but really fundamental yes or no questions. This is where the real power starts. And a language for those yes or no answers, it's called a Boolean. It's just a simple data type that can only ever be one of two things, true or false. I like to think of it like a light switch. It's either on or it's off. There is absolutely no in between. Now, this slide here is one of the most important distinctions you'll ever learn in programming, the single equals sign versus the double equals sign. With one equals sign, age equals 30, you're making a statement. You are assigning a value. You're telling Python a fact. But with two equals signs, age equals 30, you're asking a question, and Python will answer you with either true or false. And these are the tools we use to ask all those questions. Is something equal to something else? Or maybe not equal to? Is it greater than, less than? These comparison operators are the absolute foundation for all the decision-making our code is ever going to do. And you see this stuff in action constantly. A while loop is a perfect example. This is a structure that literally runs on a condition. The code inside this loop, it's going to keep running over and over and over, but only for as long as that variable a is less than 10. The very moment a hits 10, the condition becomes false and the loop just stops. But, you know, real life is messy. What if a decision depends on more than one thing? What if you need to check if it's raining and if you remembered your umbrella? For that, we need to start combining our questions. And this is where our logical operators come into play. It's pretty simple. With and, both things you're checking have to be true. With or, you just need one of them to be true. And then there's not, which just flips the result. True becomes false, and false becomes true. So when you use these, you're not just asking one simple question anymore. You're actually building a kind of a decision tree. This is what allows your program to navigate all these different paths based on multiple conditions. It's how code starts to handle real-world complexity. So let's put all the pieces together. How does all this, the math, the comparisons, the logic, build into the most common decision-making structure in Python? Let's talk about if, elif, and else. This is where it all comes together. So we start with a simple if statement. The code gets to this line, and it asks a question. Is the score greater than or equal to 90? If the answer is true, it runs the code inside that block. If the answer is false, it just skips right over it. Simple as that. Okay, but what if that first check fails? Well, that's where elif comes in. It's really just a short way of saying else if. Python only checks this if the first condition was false. It's like a chain of questions, one after the other. And the final piece of the puzzle is else. You can think of this as the catch-all, the safety net. If none of the if or elif conditions turned out to be true, the else block will run, no matter what. So in our example, since the score is 85, the first condition is false, but the elif condition is true. The program prints grade B, and then it stops checking. It found the first true path and followed it.
Okay, let's just take a quick step back and look at the big picture here. Why is this journey from simple math to complex logic so incredibly important?
When you really boil it down, it's a simple three-step dance. First, you use arithmetic operators to calculate all the values you need. Second, you use comparison operators to compare those values and ask true or false questions. And third, you use logical operators and if statements to decide what your program should do based on those answers. Calculate, compare, decide. That's the core of it.
And that's really the big takeaway. These operators aren't just features of the language. They are the fundamental building blocks. When you master these, you're not just writing lines of code anymore. You're mastering the ability to control the flow and the logic of any program you can imagine. They are absolutely essential.
And that leaves me with a final thought for you. Now that you see how a program makes choices, think about your own day. What's a simple decision you make all the time? I don't know, choosing what to wear based on the weather, or what to eat based on what's in the fridge, that you could now map out step by step as a logical path in code. Pretty cool to think about. Thanks for joining me.